Okay, let's go ahead and get done with this last page. This is part 3. This is negative exponents. So anything to the 0 power is 1. This is very important that you guys know this. So that means that if it's 5 to the 0 power, it equals 1. If it's x to the 0 power, it equals 1. Anything to the 0 power equals 1. And we're going to show why this happens by solving this problem. X to the 5th divided by x to the 5th. So let's expand it. X to the 5th is 5x's divided by 5 other x's. Any number divided by itself is 1, so they cancel. These cancel, these cancel, these cancel, these cancel. It does not leave it with 0. We don't have 0 here. We have 1 because all these numbers are the same. It's like saying, forget that they're x's. Maybe it makes more sense to use a 5. 5 divided by 5. Just because they cancel doesn't mean it's 0. 5 divided by 5 is 1. You can put it in your calculator and check. 5 divided by 5 is 1. So any number or letter divided by itself is 1. And if they all cancel out, it's just the whole thing is 1. So if you subtract 5 minus 5, just like in the previous lesson, any of these that can subtract would equal x to the 0 power. 5 minus 5 is 0, which would be 1. And again, that's 1 because you can cancel all of these out and it equals 1. So I want you guys to know anything to the 0 power equals 1. Okay, so here's what we're going to do. When it says rewrite without the negative exponents, here's how to do that. We really, on this paper, did not get into the negative exponents very much. Where's one that would matter? Oh, right here. So if you guys look at this one technically 4 minus 5. 4 minus 5 is negative 1. So technically this became h to the negative 1. And what did we do? We actually just flipped it to the bottom and left it alone and made it positive. So anytime you have negative exponents, they're going to flip to the opposite spot and become positive. So let me show you how that works. 6 just stays 6. C to the 3rd just stays C to the 3rd. But D to the negative 2 is going to flip to the bottom, and once you move it to the bottom, it becomes positive 2. And none of these are the same bases, so you can't do anything with anything else, so you're done. Okay, again, all you want to do is take your negative exponent and move it to the opposite spot. Currently, it's on the top. This whole thing is on the top over a hidden invisible 1. You move it to the bottom, and it becomes positive, and you're done. Okay, let's try this one. 6 is positive, stays up top. X to the 4th, positive, stays up top. X to the 10th, negative. So we're going to move it to the bottom, and once we flipped it to the bottom, it became positive. And now you could either see where your x's are going to end up, or you can expand it if this helps you. The 6 is there, and then we've got 1, 2, 3, 4. On the bottom, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These cancel, these cancel, these cancel, and these cancel. So it leaves us with 6 x's on the bottom. So your final answer on here is going to be 6 over x to the 6th. Okay, go back and rewatch this if you're not sure. Number 18, 2 to the 0. Well, first we've got to distribute this little 4. 4 goes to this and this. It goes to each of the bases. So 2 to the 0 times 4 is 0. X to the negative 3 times 4 is negative 12. Okay, anything to the 0 power is 1. If it's a negative, it's going to flip to the bottom and become positive. So my entire answer on this one is 1 over x to the 12th. Okay, and I'm not going to leave that hidden invisible because it's the numerator. You can't just have nothing up top. So you have to put the 1. It'd be like saying 1/2. You have to keep the 1 up top. All right, 19. These subtract. If you expanded this, there'd be 12 up here and 5 down here. If you canceled them all out, it would leave you with 7 up top. Okay, here's where it's a little tricky. This is a negative, so it's going to flip to the bottom. This one is already on the bottom, and it's not negative, so we're going to leave it there. So we first have b to the 5 at the bottom, and now we flipped the b to the 3 also at the bottom and made it positive. Day 1, we had a lesson on when you have the same base, the numbers and the exponents get added. So b and b is going to become to the 8th. So our final answer is a to the 7 over b to the 8th because I added the exponents. All right, this is getting really tricky. 0 goes to everything. So once I give a 0 to everything, everything is to the 0 power, which is 1. Anything and everything to the 0 power is 1. All right, the 4 goes to the g to the 3rd and the g to the negative 2. So it's going to be g to the, those get multiplied, 12, and g to the, those get multiplied, negative 8. Negatives have to flip to the bottom and become positive. So that's going to be g to the positive 8. Okay, if you think about this expanded, there's 12 g's on top, 8 g's on bottom, cancel all of them out, and there would be 4 left on top. And you can put it over 1 if you want, or you can just leave it. All right, 22. 3 goes to the 4, goes to the c to the negative 5, goes to the 8, goes to the d to the 0. So we first have 4 to the 3rd, c to the negative 15th, excuse me, over 8 to the 3rd, d to the anything times 0 is 0. And I'm going to go ahead and just cancel that off because that's going to be 1. 1 times anything is just 1. So it's just going to go away. So 4 to the 3rd power, I don't know what that is. 64. 64, c to the negative 15th over, I don't know what 8 to the 3rd is either. 512. All right, c to the negative 15 is going to have to flip to the bottom and become positive. So it's 64 over 512 c to the now positive 15th because we moved it to the bottom. And I don't know if 64 over 512 divides. Does it? I don't know. 1/8, yeah it is. So it's 1/8, so I'm just going to leave it 1/8 c to the 15. Okay, there's that one. 24. 2x to the 3rd, I'm just going to leave 2x to the 3rd. This, though, gets multiplied. It becomes x to the 8th. And this is going to stay 8x to the 11th. Okay, separate it out. You can add their exponents. So we've got 2x to the 8, 9, 10, 11 over 8x to the 11. All these get canceled with all of those, and it leaves 2/8, which is 1/4. All right, last one. 4 to the 4th, I have no idea. 256. 4 to the 3rd, 64. 4 squared is 16. 4 to the 1 is 4. 4 to the 0 is 1. Anything to the 0 is 1. And then it starts getting tinier. You have to flip it to the bottom, and it becomes a positive 1. So that's 1/4. You have to flip it to the bottom. If there's nothing up top, there's a hidden invisible 1 up top. 4 squared is 16. And it would just keep going. So I want you guys to see how huge the number is, and then it becomes 1, and then it becomes getting really tiny, tiny, tiny fractions quick. So the pattern on the left side is exponents are decreasing by 1. And then the pattern on the right side is numbers are decreasing. They're decreasing exponentially. That's a word we'll talk more about. Decreasing exponentially by 4. Okay, go ahead and try your BuzzMath for today, and we'll see how that goes.